The concept of linear relationships illustrates the direct correlation between the behavior of one independent variable and its dependent variable under certain conditions, which is known as a rule. Linear behavior can be thought as a straight line resulting from an input-output process of numbers, which produces values on a given slope, known as a gradient. The gradient depicts the proportionality of this linear relationship. A directly proportional linear relationship will therefore produce a gradient of 1, which can be seen as a straight line splitting the x and y axes at 45 degrees, with the rule of y equals x. Example number 1. One day, Sarah was hungry, so she decided to go and buy some lollies. If one lolly equals $1, then how much would 6 lollies cost? As you can see, the rule is said in the question. One lolly equals $1, which is x equals y. So if we drew up a table, with 6 columns, two, 3, 4, 5, 6, it would then equal to 1, 2, 3, 4, 5, 6. Now, because we drew up the column, it makes it easier for us to see what equals to what. So, if she wanted 6 lollies and 1 lolly equals $1, Sarah ends up buying the 6 lollies for $6. So, to conclude this example, we write, therefore, Sarah buys 6 lollies for $6. Example number 2. Sophie went on a deal with her grandpa, saying that every week he needs to give her $2 for pocket money. How much money would Sophie have after 4 weeks? So, this question is asking, how much money would Sophie have after 4 weeks if her grandfather is giving her $2 each week? To understand this better, we'll first put it in a table. Okay, now, if you've done that first, we need to decide who should we make x and y. In this situation, Sophie would be y and grandpa would be x. Now, because it says 4 weeks, we will put in 4 columns. 1, 2, 3, 4. Okay, so now, to find the rule of this, if you put in y equals, because Sophie is going to be the main number, you put in y equals x plus 2. Now, this is because x plus 2 is Grandpa plus the 2 equals Sophie. And that is the equation. So, if we now work it out, saying x plus 2 for every single one, if 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, and 4 plus 2 is 6. So that is how you work it out. Now, once we just get all of this off, we can now put this on a graph. Let's write the rule here so we don't forget. Y equals x plus 2. Okay, so this axis is x and this axis is y. Now, x is 4, so we put 1, oh, sorry about that. One, 2, 3, 4. And then we write that down. And then, once we found out what the y-axis is, we write 3, 4, 5, 6. So, we can do that by going in ones to make life easier. So we can go 1, make sure you got every single one equal, 2, 3, 4. Let's rub that off a bit. 5, 6. That 6 looks a bit too big, but as long as these areas look equal to you, it's fine. Let's make sure it's in line with this area as well, the x-axis. Okay, now if we have a look at this table over here, it says 1 equals 3, 2 equals 4, 3 equals 5, and 4 equals 6. So let's do the first one. When we go to the x-axis, we look for number 1, which is right over here. And then we go along the y-axis and look for number 3, which is right over here. Now, you have to make sure that these are in line. So, let's get a different colour. And inline these. Oh, that's not pretty straight. Sorry about that. Okay, now inline these, and inline that. And that is the point for that one. Now, if we go to the second one, which is 2 equals 4, on the x-axis you look for 2, which is here, and the 4, which is here on the y-axis, and then you simply plot them on the graph. And make sure it is as equal that you can possibly make it. And that is not that equal. Redo that. The second one, which is 3 equals 5, you go to the 3 on the x-axis and you look for the 5 on the y-axis, and you plot it. That's not really straight, but and that's over there. If you are doing this on a gridded paper, it will be much easier, and it would be more preferable to use a ruler. Okay. Now if you look at the 4, 6, you go for the 4 on the x-axis and the 6 on the y-axis, and then you plot it again. And this is the last one. And plot it, which is there. And the question does not ask this, but if it did, this graph has a linear line to it, which is a straight line. So that's the graph, and this is the table. And before you do, I was actually supposed to include this at the beginning, but before you actually put it on this graph, you have to make it nice and clear. Let's make more room. You have to make it nice and clear that you are able to substitute it, because if you're not able to substitute it, you will have your graph and everything completely wrong. So if we look at this over here, the equation that we solved earlier, y equals x plus 2, just pick any of these numbers here, but obviously in the same column. So for this one we'll go with 3 and 5. So if we substitute it, so if y equals 5 and x equals 3 plus 2. So from this we can obviously see that our equation is correct and everything else is correct, because 3 plus 2 does equal 5. And yeah. So never forget to first substitute it at the beginning to always check if you're correct, because if you don't, then you'll get most of your answers wrong. So, in conclusion, always plot everything into your table first, whatever it is. You always have to do it just to outline it out. X at the bottom, X at the top, Y at the bottom, just to lay everything out and to understand everything much more better. Do not ever forget to substitute anything into anything. For example, to give another example, x over y, 1, 2, if the equation was y equals x plus 1, just double check if 2, 1 plus 1, so that was obviously correct. And I guess that's it. Just make sure you always pick out the most important points in every single question. And yeah, so thank you for listening, and I hope you have enjoyed. By Sarah Yildiz in 8GB. Thank you.